In this video, we'll continue our discussions of planes and three space. So, a couple notes here. These make sense. We're not going to go through the theory because you could just kind of see it. Two planes are parallel if their normal vectors are parallel. This makes sense. They're both normal. So if the normal vectors are parallel, then the ones that are orthogonal are also going to be parallel. The same with orthogonal. If two planes are orthogonal, then their vectors, normal vectors, are orthogonal. So we can do vice versa. And then the last thing, the angle between planes is equal to the angle between their normal vectors. So we don't need to calculate from the plane. We just need to grab their normal vectors. So take plane 1. That is a plane in general form. So in 1 here, we just grab our coefficients, 5, -4, -1. Grab your normal for your second. That's going to be -2, 1, -2. And those are our two vectors. We just got to find the angle between that. So I'm going to write the formula. Cosine theta is equal to the dot product of those two over the magnitude of n1 times the magnitude of n2. There we go. So I need all those things. I like to do them off to the side first. N1 dotted with N2. Okay, that's going to be -10 minus 4 plus 2. So the dot product there is a -12. Magnitude of N1 is the square root of, okay, so that's, I'll do that in my calculator, 25 plus 16 plus 1. I guess I didn't need to do that in my calculator. That is 42. The magnitude of normal 2 is 489. Square root of 9, which is nice, pretty 3. All right, so cosine of theta is equal to -12 over the 3 times the square root of 42. I'm not going to worry about too much of that. I know theta now is equal to the inverse cosine of that thing. So I'm going to plug that in. Inverse cosine of -12 over 3 times the square root of 42. All right, I got 2.23599. I'll just write them all through. 82 rad. That's radians. I want to go to degrees, so I'm going to divide by 180 and times. Oops, I lied. Divide by 180 or times by 180. Divide by pi. My bad. Hold on. Let me do that again. Messing up on my calculator. Okay, I got that radians. Now, radians, if I'm in radians, I want to times by 180 and then divide that by pi. Okay, so I got roughly 128.1 degrees. The angle typically, I think, is they want the one in between. So we're going to do 180, the acute angle. Right, if I have two angles, I have this angle and I have this angle. They want the acute one. So I'm just going to minus 180 minus 128.1 gets me 51.9 degrees. On a test, you give me either angle, I would be happy. All right, so to find angles between planes, we find the angle between the normals. All right, what if we were trying to find the angle between a line and a plane? Let's do a little bit of analysis here. We're trying to find phi there. So if I'm trying to find phi, I can work off that I have a normal vector. So I'm going to draw this normal vector here. My normal vector. Let me fix that. All right, there's my normal vector. I can actually create a vector from this line as well. I'm going to put it right here. And I can create a vector that goes the path of the line describing that. So we'll call that v. Now, I can use n and v to find theta, right? I can use cosine. Cosine of theta is equal to n cross v over the magnitude of n times the magnitude of E. And then I would do theta is equal to inverse cosine of that business. And then I know if we look at our triangle, we created a right triangle here. Okay, whatever. I'm just going to do that, not think about it too much. Right triangle. That means that the phi and the theta and add to 90, right? Because theta plus phi equals 90 degrees because the triangle adds to 180. So to find phi, we're just going to take 90 degrees and minus theta. All right, so that's how you go about finding an angle between a line and a plane. Okay, so I'm going to shrink this down for space. An intersection of a line and plane, we're going to do an example of this next. All we have to do is plug the line into plane. Okay, so I gave you the method to find an angle between a line and a plane there. You would just follow my logic through that we could find the angle between the directional vector and a normal, find that angle, and then subtract that from 90, and that gives me the angle between the line and the plane. The intersection of a line and a plane, we just plug the line into the plane. Okay, so look at this example here. It says find the point of intersection of the plane and line. The note that we just wrote just says to write plug the line into the plane. So notice that the line has definitions for x, y, and z, right? X equals this, y equals that, z equals that. So I'm just going to plug each one in. So x plus y equals -2, and I'm going to plug each one in. 11 plus 4t plus 2 minus t equals -2. It's okay that there's no z. And then now I combine like terms. I got 13 plus 3t equals -2, and I'm just solving for t in this case. I'm minus 13, I got -15, which means t is -5. Okay, so that means that they do intersect, and where they intersect is when t equals -5. So all I have to do now is take that and plug it into each component. So x equals, and I just use the formulas above, 11 plus 4 times -5. So x is going to be, that is a -9. Y is equal to 2 minus t, so 2 minus -5, which is a 7. And then the last one, z equals 5 plus -5, which is 0. So the point of intersection for our line and our plane is -9, 7, 0. So we just plug it in, find t, and then plug it into our line to actually get the point. All right, and that covers that.